Hello everyone, today I'm going to explain how 3D printers work and not just how extruders work, which are the standard 3D printer that everyone knows by now, the kind that you can buy at any hardware store nowadays, but also how other 3D printers work. There are two main types of printers, that is extruders and powder fusing 3D printers, and then there are also a few modifications and special types. But first I'll start off with these two, and I'll start with the extruder, which we all know. Uh, it's the basic nozzle filament extruding printer. I've got a few videos of those. I have one of these. Many people have one of these. You can buy them pretty much anywhere. They've been explained quite often too. They have a nozzle which is heated up. They usually print plastic that melts when it goes through that nozzle at around 200 degrees Celsius. They then have a build plate, and the nozzle is moved over that build plate. The exact mechanism by which this is done can change. Also, some move the nozzle in 3 dimensions, some only move the nozzle in 2 dimensions and then move the build plate up and down. But the general principle is always the same. You have a build plate, you print out filament to squeeze it through a tight hot nozzle, and it melts, and you can deposit it on the build plate. You can deposit it on itself and thus print in many layers up and up and up. You can also have a little bit of overhang that kind of works, and if it is too much, you'll need some kind of support structure that you can then break off. But that aside, it is rather free in what kinds of forms you can make. It's rather versatile, though it does have a lot of limitations in terms of material, since you need a nozzle that can print it, and it has to be in a printable state when melting or almost melting. That is, any material that when melting just turns into a very fluid liquid and just runs away doesn't quite work. It has to be rather viscose, and it also has to be a material that can be melted at all. Many plastics actually decompose long before melting, and thus they can be melted, but they can't be melted and then cool down again, and then you don't have the same material anymore. It decomposes. They are also a bit limited in their shapes they can print, but they're quite common, and you can do a lot of things with the filament too. You can put in wood fibers or carbon fibers to reinforce it in certain directions, or make it look cooler in the case of wood, because it doesn't really make it that much stronger. Uh, there's also a lot of development going on there because they're quite common, so pretty much everyone interested can buy one and experiment around with them. The second really common type is the powder or material binding printer. The most common among these are Sinters, but they all work by a similar principle too. They deposit layers of powder or other granulate kinds of substances or semi-liquids, and then they bind or solidify these at certain points. So you might start by laying down a 0.1 millimeter layer of powder. Then in the case of a laser melter, for example, you might have a laser running over this and melting this powder at certain points and not melting it at other points. And the points where it melts, it binds together to one solid piece, and if you melt it at 2 points right next to each other, it kind of melts together into one, and so you can print a shaped layer, and then you deposit the next little layer of powder and melt that at certain points. A more common but very similar deviation of this is the sinter or laser sinter, which doesn't exactly melt the material but basically does the same. It heats it up just before melting, and it's technically not melting yet, but it gets kind of softish and still binds together as if it was welded or melted together. although it's technically not melting, but the idea is pretty much the same. These can print most meltable plastics as well, but they can also print metals, as they don't really need a nozzle. They only need some sort of a laser to heat it up from a distance. And if you start laying down powder, several layers of powder before you actually start printing, you don't need the interior of the printer itself even to withstand the melting temperature. And they also don't really need a support structure, since the shape you're printing is essentially supported in the powder itself. They are thus a little bit more versatile in shape, though you can print almost any shape with an extruder. It does take a bit of support material sometimes, and in this case you can print almost any shape except any actual hollow shape. That is, if you print a hollow shape with an extruder, you end up having air inside that hollow shape, and if you have a hollow shape with a sinter, then you end up having powder in that hollow shape unless you drill a hole to empty the powder out. So that's one little problem, but as long as you don't really want to print perfect hollow spheres with it, it works really well. It can do many materials, it can do very fine structures, and there are also a few projects that work on adding a bit of versatility, adding some extra features like laying down carbon fiber composite reinforcements between those powder layers, and then having those basically fused into the shape you're printing, and then you can print carbon fiber reinforced plastics, which are really light and really strong. And another slight variation of this is essentially the photopolymerizer, which uses a liquid, or a liquid containing what's essentially chemically a plastic, but it's a liquid, and you have some kind of chemical reaction so that it solidifies when it is exposed to very bright light. And then you can concentrate laser beams into one point, and at that point you can then solidify that, and then you can also go layer by layer by layer and move it up through a liquid, and the polymer in this case basically floats in the liquid, so it's supported by the liquid, which isn't quite as good as supported by a powder bed, because a powder bed still is, it's not quite a liquid. So in a powder bed you can print like completely free objects, and in this case if you print any object that isn't connected to the build plate in any way, then it will just float off while you're printing it. Whereas with a sinter that uses a powder bed, you can essentially print any shape freely, kind of floating, though it's not really floating, it's supported by the powder bed, but you can print a shape freely positioned in the printer's build space. Now the rest are basically deviations of the extruder process, where you have there's one process where you have a basically powder fed extruder that also has a nozzle and works its way up with a support structure just like an extruder, but instead of feeding it filament, you feed powder into the nozzle. And then there's a type that can actually print metal in a way that is similar to an extruder, by not using a nozzle at all, but using a wire instead of a filament that is not squeezed to a nozzle, but just extended and then melted by a laser or electron beam. And it essentially works like a welding machine on a robotic arm. And it prints its way up just like an extruder and can print larger metal structures, though not as precise or fine as in a metal sinter. Then there's a few variants of extruders that essentially are still extruders but are often seen as a variation. That is, the extruder of course can have a different specifications and different nozzle diameters. So there are, for example, extruders with very, very thin nozzles that print really slowly but can print incredibly fine structures, and in the opposite there are of course extruders with extremely thick nozzles that can't really print any fine structures but can print very big structures really quickly. Now this was a little overview over the common types of 3D printers. If you have any questions, you can put them in the comments. I might make another video about more detailed infos about 3D printing, but for now I'm planning to make more about aerospace technology and astronomy. However, I hope you found this kind of interesting, and as always, thanks for watching.